All right, here we go. We're going to do the last section of chapter 5. This is proof involving points on the perpendicular bisector of a line segment. So it's very important that you understand what the perpendicular bisector of a segment is. So right here, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay? So for example, here we have PQ is the perpendicular bisector of AB. So this point P is equidistant from A to P is the same as the distance from B to P. Okay, so let's go ahead and give this a try. So we're going to send to proof that PQ is the perpendicular bisector of AB. Okay, so if I draw this out, here is my line segment, my other one. So Q is here, A and B, and this is P up here. Okay, so when it says perpendicular bisector, it means that it forms a right angle where the two lines intersect. So angle AQP is a right angle. So angle AQP is a right angle. Okay, and that's from the definition of a perpendicular bisector. Then the other one is also a right angle. So angle BQP is a right angle. So angle BQP is a right angle. Okay, and that's definition of perpendicular bisector as well. Okay, so now what we're really trying to do is we're trying to prove that these two triangles are congruent. Okay, if we can prove that these two triangles are congruent, then we can prove that AP equals PB. Okay, so we're trying to prove those two segments, those two sides of the triangle are congruent. All right, so because both of these two angles are right angles, we can say that the two angles are equal. Okay, so AQP is congruent to angle BQP. Definite, and that is all right angles are congruent. Okay, we need to validate that. Okay, now it says it's a perpendicular bisector of the segment AB. Okay, so the segment AB is being bisected by the line PQ. So bisects mean it divides the segment into two equal lengths. Okay, so because PQ is bisecting AB, it means AQ equals QB. Okay, so we're going to say segment AQ is congruent to segment QB. And that is also the definition of perpendicular bisector. So the perpendicular bisector, remember, tells us a lot of things. All right, lastly, we have two things. We have this side and we have an angle. Now we're looking to see if these two triangles share a side. Okay, if I look at them closely, I can see that they share this side in the middle. Okay, so the segment PQ is congruent to the segment PQ, and that is the reflexive property. All right, now we've done our three things to prove triangles are congruent. We have a side, then we have the angle, then we have another side. So there's our three things. So we say triangle AQP is congruent to triangle BQP. And that is, we have side, angle, side. Okay, side, angle, side. Validate. So we're trying to show that AP equals BP. So AP equals BP. Okay. First, we have to show that the two sides of the triangles are congruent. Okay. So we say segment AP is congruent to segment BP. Oops, did not put my segment in there. So segment. And that is the CPCT property. Okay, that's because if I take this triangle on the left and fold it over that line down the middle, side AP will line up with the side PB, their corresponding parts. Okay, since we showed that the two segments are congruent, okay, we can send this last line to the proof. I know that this seems redundant, but this is inferring segment, this is showing distance. So this is the definition of a segment, or a definition of congruent segments. Definition of congruent segments. Okay, right there. Definition of congruent segments. Okay, and then check. All right, I'm going to do one more of these with you guys. So here I have the two lines intersect. That was not a very straight line. Okay, so T is up here. I have S down here, N and P. So we're trying to prove the two triangles are congruent again in order to show that the side SP, this is P up here, the side SP is congruent to PT. So these proofs are very similar. You pretty much do the same one every single time, okay? They tell us that PN is this perpendicular bisector of ST, okay? So perpendicular bisector means that it intersects at a right angle. So both of these two sides are right angles. And then it also tells us that the two segments, so TS, is divided into two equal parts. Okay, so we're going to send that to proof. We need to show that SNP, angle SNP, is a right angle. That's from the definition of perpendicular bisector. Then we need to show that angle TNP, is also a right angle from the definition of perpendicular bisector. Okay, because both of those two angles are right angles, they are equal to each other. So TNP is congruent to angle SNP, taking the two angles from line 2 and line 3, because all right angles are equal. Okay, so there, we've shown that those two angles are equal in the middle. Now we need to show that these two segments here are also equal. So we have segment SN is congruent to segment NT, and that's from the definition of perpendicular bisector as well. Okay, so we need one more thing. We've done two things trying to show that the triangles are congruent. We need one more, okay, because you always need three things. So looking at these two triangles, we're looking for if they share a side or an angle. So I can see that they share this side right down the middle. Okay, so because they share that side, it's equal to itself. So PN is congruent to segment PN. And that's from the reflexive property. All right. So we've shown three things. We have a side, we have the angle in between, and another side. So the triangle SNP is congruent to the triangle TNP. Okay. Triangle SNP is congruent to triangle TNP. All right, and that is from the side angle side property. All right, we are trying to show that SP equals PT. Okay, so first we have to do it in terms of the sides of a triangle. So we say that the side SP, so segment SP, is congruent to the side TP. And that is the CPC-TCT property. That's like if I take this triangle on the bottom, fold it over that line on top of the other one, the side SP lies on top of TP. Okay? So since we showed that the segment SP equals the segment TP, we can show the distance, so the last part, SP equals TP from the definition of congruent segments. Okay? All right, let me know if you have any questions on that.